Hello, in today's experiment we will determine the solar cell characteristics. Here is the typical solar cell which converts optical energy into electrical energy. When light falls on the solar cell, the negative ions are attracted towards the N terminal because of the positive immobile charge carriers there. So then the electrical energy is being formed because of the optical energy. This solar cell is connected in series with this microammeter and with the voltmeter as a parallel, and here there is a variable load resistance and a lamp since we are performing this experiment in the lab.
When we vary the load resistance over here, you can see that the voltage is increasing, at the same time the current is decreasing. So when we look at the typical graph of I versus V, it looks something like this. The graph is not a straight line, which is what one would expect. Instead, it's a curve in this fashion. This is because for a given intensity of light, the power output of a solar cell will remain constant. The ideal characteristics would have been the rectangular curve that you see over here. This is the open circuit voltage when the resistance is maximum, and this is the short circuit current when the resistance is minimum. The real characteristics differ from ideal characteristics because of internal resistance of the cell. So, if we determine the difference between the real characteristics and the ideal characteristics, we will be able to find out the internal resistance of the cell. So the delta V over here is the difference between the ideal characteristics VOC and the real characteristics V. We plot a graph of delta V versus I, which is a straight line passing through the origin. Likewise, delta I is the difference between the real current I and the ideal current ISC. We plot a graph of delta I versus V, which is again a straight line passing through the origin. The slope of these graphs gives the value of internal resistance of the cell, that is the series resistance and the shunt resistance. The other quantity which we determine is the fill factor. The fill factor is defined as Im Vm upon ISC and VOC.